This is Mr. Thomas live streaming on YouTube. We are about to get the party started. I'm going to be going over videos, problems, requests. I'm going to give you strategies on how to be successful in mathematics. I would say about 80% of it is understanding the question. Understanding the question. Once you understand the question, you can pretty much do whatever you need to do. The problems become a little easier. Let's take a look at 4.3 in statistics. And let's take a look at problems 11 through 16. Let me start with 10. Let's see what 10 looks like. Okay, yeah. The concentration label or the ratio label, correct dosage, wrong dosage. So use a 2x2 table. Let's move on. Let's move on to 11. It says, in the table below summarizes results from a study of people who refused to answer survey questions. A pharmaceutical company is interested in opinions of elderly. What is the probability that the selected subject is someone 60 and over who responded? Well, I actually know the number of people who responded that are 60 and over. There's 207 of them. Well, all I'd have to do to calculate the probability out of this whole group that someone responded that's 60 and above will be 207 over the total amount of people. The total amount of people. I don't know what the total amount of people are, but I can calculate it out. So what I'll do is calculate out the total number of people by adding up all of the numbers. That's 78 plus 260 plus 250 plus 141 plus 143 plus 207. And let me just double check that. That's what? 78, 260, 250, 141, 143, 207. And I'm also going to add the other column as well. But what I'll do is first, I'll figure out what that is. And let's just add the other column as well. So that's 14 plus 23 plus 36 plus 29 plus 38 plus 60. And so what I'm getting is 207 divided by the full amount, which is 1279. And they want me to round this off to 3 decimal places, so that's 0.162. .162 is good. All right. Doing well. We are doing well. So this problem is similar to the last problem. The only difference is we don't have a chart. We don't have a chart. All right. So we can create the chart, or we can just do another problem that already has a chart. Let's see if the next one has a chart or not. Yeah, this one has a chart. This one was actually done for us. Let's look at another one. This is another one with a chart, and then maybe we'll come back and do the one with the chart if someone really wants to see the one with the chart. Pollsters are concerned about declining levels of cooperating among persons contacted in surveys. A pollster contacts 78 people in the 18 to 21 age bracket and finds 68 of them respond and 10 refused. When 207 people in the 22 to 29 age bracket are contacted, 243 responded and 44 refused. Suppose that one of the 365 people is randomly selected. Find the probability of getting someone in the 22 to 29 age bracket or someone who has responded. So that was not too bad, actually. So we'll come back to that one. Actually, maybe we should do this one now. Maybe we should take a closer look at this one. They did give us all of the necessary information. Let me go back for a second there. Wait a minute, we went back too far. They did give us all of the necessary information. Let me zoom in a little bit on this. Everybody can see this clearly. A little bit of lag. So we basically need to create this chart. Pollsters are concerned about declining levels of cooperation among persons contacted in surveys. Alright. So what we'll do is create this kind of a chart that will summarize the information. And the first thing we know is that there's different brackets. There's the 18 through 18 through 21 bracket. There's 22 through 29 bracket. And then there is the it looks like those are the only two brackets there that we're going to be working with. And then there's two different categories. There's the responds and the ones that did not respond. So we'll put here respond, not respond. And what they're saying is that 78 people in the 18 to 21 bracket was responded. 68 responded to the. So there's the total people that was reached was 78. 68 responded, 10 did not. So I'll put the total here. And in the other bracket, 287, okay, let's get this going. 287, and that is broken up into 243 and 43. Okay, so the total amount of people in the survey is 365. And we can also figure out the total number of people who responded, and we can also figure out the total number of people who did not respond. But let's see what the question is asking us here. It says find the probability of getting someone in the 22 to 20 age bracket who find the probability of getting someone in the 22 22 through 29 age bracket, or someone who responded. So there's actually two things going on. We need to get the total number of people in this 22 through 29 bracket. There's 287 of them. Maybe I should have changed the color that time. Yeah. Whoa. There we go. Easy, easy, easy. Okay. Well, the probability of that event will be 287 out of the full 365. But now what we have to do is figure out, well, what's the probability? And then it says, or someone who responded. Well, I need to know the total number of people who responded. And so I need to add 243 with 68 together and get that amount. That's 311, right? That total. And so what we can say is that's going to be 311 out of a total 365 again. And this one, just to complete the table, is 53. Wait a minute, why are we short one person? That's really odd. No, I think that could just be the way the table broke apart. Could be a half and it was rounded off or somehow, but 311 plus 53 turns out to be 364. But this one adds up, so it's okay. But the problem is there's overlap. If we add these two right now, there's actually overlap because we counted 243 twice. So we actually have to subtract out 243. We can't count those group of people twice. We're trying to count the exact number of people who were either in this age bracket or someone who responded. Essentially, and I can change colors here again. Essentially, it's just going to be, let's go with red. It's really just going to be this, and this over the original amount. And that's the amount we get when we only include 243 once. So it's just going to be 311 plus 43. And that should do it. That's actually what 354. Let's see if that will work for us. Just get our calculator out. Divided by 365. And we're getting 0.9. Now if I round this off, it's going to be 0.970. Actually, hold on. Oh. Let's pull up our chart for a second. And let me do the math with my calculator. Let's make sure we're precise here. $68 plus 243 plus 43. 354, and that's out of we should be good there. person is in the 22 through 29 age bracket or responded. Now, in order to be in that bracket, there's 287 out of, so we're doing, that's really odd. Let's get that right there. 287 out of 365 plus 311 out of 65 minus 243. Looks like our math is right. That's good. Let's see. We can also do it this way. 287 plus 311 plus, and actually minus 243 again. $355. .973. For whatever reason that one little decimal, some number is being miscalculated. Some kind of flaw. There's some kind of flaw in this problem. It's just pretty strange because they actually gave us the certain numbers. They told us the total, and for whatever reason it seemed like it wasn't working out properly. Really odd. Yeah. They gave us 78, 287, and 365. And then they also told us that it was 287, 78. It was broken down into 243, 43. Oh, it's actually 243 and 44. Ah, 243 and 44. Okay, so that 44 was there, so that makes that 54, and that makes it 55. Okay, so then that's the right answer there. Okay. Let's see if anyone has any questions or comments or anything like that. We are still live. We're making videos. We're doing problems. We could go over some pre-calculus. If anybody wants to go over some pre-calculus, you let me know. I will be checking my messages. The probability that a randomly select person refused to answer the survey question or is below 22 or is older than 59. Okay, there's a lot of things going on in this problem. Let's see if we can. I'm going to try to write on the screen this time. And this is what I'll do. So, yeah, this should be fine. They want us to find the probability that a selected person refused to answer, so the sum of all of this or the person is below 22 or the person is older than 59. And and then we would be done with the problem. So we already see that there's some overlap with the 56 and 10, so we only need to count them once. So we're really just going to count 70, 10, 19, 32, 25, 34, 56, 199, and divide that by the total number of people, and that will give us our answer. Alright, so we bring up our calculator here. Let's see. Seems like my screen got frozen out. Let's move that up some, and let's get our calculator back out. Alright, so we're going to add up 70, 10, 19, so on and so forth, all of those numbers. 70 plus 10 plus 19 plus 32 plus 25 plus 34 plus 56 plus 199. Let's double check that. 7, 10, 19, 32, 25, 34, 56, 199. And then over the total amount. So what I'll do to get the total amount is take that 455 and then add these other four values. 252 plus 242 plus 133 plus 135. So what I've got is 445 divided by 1207. And they want us to round this answer to the nearest thousandth, the three places, so 0.379. I know, this should be correct. So let's see. Oh, tell me I miscalculated again. Let's double check this. It's 70, 10, 19, 32, 25, 32, 25, 34, 56, 199. That gives me 445. And then if I take that and add 252, 242, 133 and 135, I get the total is 1207. So all we did was the probability that a randomly selected person refused to answer the question. Refused to answer or below 22 or is older than 59. Actually, it should be 0.369. I put 0.36. The answer is 0.369, and I put 0.379. It should be a 6 there. Okay. So for this, you just construct your table, and you can do it that way. we'll probably do now is look at some pre-calculus. I think there might be some pre-calculus questions, like from 3.2. Let's look at a couple of these problems. What are the zeros? The zeros are of f are this. Well, the zeros are going to be -5 and -2. Find the zeros of the polynomial function and give the multiplicity for each zero. State whether the graph crosses the x-axis or touches the x-axis and turns around at each zero. Well, it all depends on if it's a multiplicity or not. What we could do is just factor this guy. Let's factor this. So my function is, I'm getting x cubed. Hold on. We can factor by grouping. If I take that minus sign, I'm not going to take it out. Put that, add a plus sign in there, and just keep the negative with the 4. Probably the cleanest way to do it. Now I can factor. I can take out an x squared. I could take out a -4. Now I can pull out an x plus 7. Now it turns out x... Actually, I can keep going. There is no multiplicity. I feel like I've done this one before. There is no multiplicity. There are 3 distinct roots. The roots are -7, 2, and -2. The multiplicity of the greatest 0 is, I would just say 1. There is no multiplicity. So we'll just say 1. Again, it would be 1 again. They all should be 1. It's kind of a tricky question. Crosses the x-axis. They would simply cross because they're zeros with no multiplicity. Now, if it had a different type of multiplicity, it would do some other things. But no, it's just crosses there at that. And one thing you can do, it's going to cross at all of them. Another thing that you could do is actually graph it. You could graph that polynomial. Let me go back and you can use your graphing calculator to actually graph the polynomial. You just type in y equals x cubed. You do plus 7x squared minus 4x minus 28, and then just hit graph. I'd do zoom square maybe. My calculator just All right, they're talking about stat plot, something about stat plot. So I guess I gotta turn off my stat plot. Maybe that's what they want. And then, okay, I can't even see it. So I could do zoom fit. Zoom fit will get it on there. Where's zoom fit at? 0. It is. It looks like it's actually jumping up. It does, but it does cross. It's just we can't see it based on that scale. But if I did a box, if I zoomed in a little bit more, let's say if I created a. It should be going up. It goes above the x-axis and then comes back down. Yeah, it did. It did. We just can't see it right now. Let me try to zoom in some more. I'm going to put my cursor right there. Zoom in. Yeah, so you can see that it does cross the x-axis and then it comes back down. It doesn't like stay flat on it and it touches it more than one place. It doesn't do that. We can zoom back out. And of course we can create a table of values and change the table the distance of the y's to every 1 unit there. It can help zero in on the graphs there. That's not too bad. All right, all right. Use the intermediate value theorem to show that the polynomial has a real zero between the given integers. So first you plug in 1, you'll probably get a negative. You plug in 4, it gets a positive. And then you can say that there does exist some number between 1 and 4 for which f of x is 0. Because this is a continuous function. And since it's continuous, it will do that. So that's pretty straightforward. Intermediate value theorem again. Use the given function to answer the questions below. Well, you can simply just graph it. Use the leading coefficient test to determine the graph's end behavior. Well, as you can see, it's an even positive number. So we know it rises to the left and rises to the right. It rises and rises. It doesn't rise and fall, it just rises and rises. Find the x intercept. So you can factor this guy. Pull out an x squared. And then we're going to have 0 and then -3 and then +3. 0 is multiplicity. At which 0 does the graph cross the x-axis? And it should cross at 3 and -3, because those do not have multiplicity, but 0 does. So it does a reversal right there. 0 was x squared, and so that's why I knew that. And if 0, 0 is 0, it does cross right there at the origin. That's where it does its little reversal. And I would say that it's even. If I plug -x inside, I'm still going to get the exact same thing, I believe. So yeah, it was even powers. And now I got to graph it. I would say this. Based on the fact that it does a reversal, it doesn't cross. It had to look something weird like that. But you could have also just graphed it and found out. Okay. I think this was helpful. This is a good start in the right direction. Just jump in, do those problems, do those assignments, do as many as you can. We'll probably come back later on with a video about the practice exam questions as well. So, hope this was helpful. I'm signing off. Alright, we do have a question. This just came in. On the midterm, will there be an area given to draw the histogram? Absolutely, there will be, and you could also use the back or additional scratch paper if there isn't enough space. We don't want that to be an issue. Oftentimes I do print a lot of problems on a sheet just to save the paper. I make it double-sided, but I don't mind if students have additional sheets that they use, and then we just staple it all up and turn it all in together, as long as you put your name and stuff like that. So that's not going to be a problem for you. You'll have as much space as you want to have. We'll also allow the cheat sheet, 1 page, 8.5 by 11, front and back. You can handwrite it or type it out. Alright. Okay guys, I think we're going to wrap it up here. It's pretty straightforward. I would definitely study those midterm practice problems if I were you. Do a good job on those. And if you have any additional questions on some of them and you want further explanation, reach out as well. Okay. Talk soon. Signing off, and I'll be back later with some more pre-calculus videos.